Okay, let's try something new. Let's try coding up, standing up. Coding up, standing up. What? Alright. Let me just figure. Hmm. I think I'm so close to. I'm so close to finding what this do. Very close, very close. Maybe if I have a session already, no? Okay, close on to the right. Do I have a session? If hopefully, yeah, very nice, very nice. So let's just open that session up. Uh, yeah, open session, session. Great. Okay, so bed. Nothing is in bed. Um, let's open this. Okay. So yeah, I was actually on this piece of code. I figured out this. I am yet to figure out what this do. Right. Okay. So I I think I put it in curiosity question and finding the 64 teacher. Did I get the latest repo? See. Okay, and we have almost there. Okay, so I'm just almost there. Don't you wrote it? Yes. Okay. So now we have so far so good. Right. So max is basically the size of the source array or the number of elements within it. Count array for all possible white values 0 to 255, 256 values. It's like a histogram. Okay. We have count pointer pointing to the count array, source pointer pointing to the source, and keeps us in bound, keeping us from accessing foreign memory. Yes. Operator accumulated some temporary variable. If the source is supposedly an array, so we will go through it and find which value of byte occurs how many times a histogram. Okay, so obtain the value of the byte and increment its count occurrence. Wait. Obtain the value of the byte and increment its count occurrence. And we have to obtain a cumulative sum of value. This piece of code sets count to 0 by default. Yeah, s equals to 0. Yes. Sum is 0. HCP is count. By default, C is 0. Okay, sum is 0. Count of 0 is 0. Here, count of 0 is obviously 0. So we store that 0. Then we feed it to sum. Okay, then we set the value of sum to whatever value that has. Okay, then we increment. Okay, ITCP is big. Okay, now map the indices to the respective position. Now this is the place where I have to think, so put something. Okay, so we go count equals to count plus the value of the source. So when I specify the value of the source pointer, I get a digit, right? And that corresponds. I think I should first let's try and make an array. Array and we have 6. Let's see, 5, 9, 7. Let's give it a 3. Then a 6. Then a 2. Okay, then we have an a an int. Oh, I forgot. Oh, it's of destination 6, and we'll say is 0. Right. Then let's call the function. So we go radix and sort 6 comma arr comma test, and there we have it. And let's just print the array itself. Right. Let's go print f then we go arr of I, then I will run this program. cc main dot c, and there we go. Okay, it said it did something. It was something. And source destination. Oh, sorry. And to destination. Yes, my bad. Okay, now it has been sorted. So position. So we have all possible values, right? So we find count base address plus the value. So for SP source pointer, right, value, let's say 5. So how many times 5 has occurred is stored in count. Then we take how many times 5 has occurred, the value of that, right, and store it here. I would like to take a look at the count array. Equals 0 I less than 256 I plus plus. There we go. Print. Uh, I go. No, first I'll go I. Then I'll go count of I. And now let's try and oh, wrong. Okay, let's try and run that. Right, gcc main.c my bud printf. Anyway, okay, so okay, so we go 0 has occurred. Okay, so 0. This is actually 2, so I might even say that it should be I plus 1. Okay, right. Okay, so we see the 3. I think it is a little. There is a little mismatch. That this is supposed to be 0, right? Then this is 0 plus 0. Then 3, though. 255 values. Okay, so here we are again. Okay, so actually what I find is when we do that, I get this is nothing, this is 0. This is supposed to be 0. Let me just write I plus 1. Okay, so right. Excuse me. Oh, I did save it. My bad. My bad. My bad. Okay, we go gcc main.c. Those are indexes and those are actual locations. So, okay, so I was to decrement one. I don't know, man. Just like okay. So simply, so you see, simply it shows that 3 has 1, right? That's 3 plus 1. Then it changes 3, 4. Okay, so this is 2, this is 3, right? Right. Okay. Maybe I should -1. Okay, but so this is actually 0. So we have 2, we have 1. Then at its 3, 1 plus 1, 2. Then we have 3. Then we have the digit 7, right? 6, I do have 6, then 7. Right, okay, so we have this. Now, then we go CP equals count plus SP of 1. So let's say 5. Okay, so we went to 5, right? We went to 5, and then we see that it has value, say, 3, right? So, 3, or in this case, it went to 5, which would be this one. It has value 3, yeah. 0, 1, 2, 3. So right about 0, 1, 2, 3, 5, 6, 6, 5, 6, 7, 3, right? Okay. Then we go and we check the value. What is it? What? Okay, no. I'm wrong here. I'm wrong here. SP has a value 5. Right? Count base address plus 5. So where will it take it? 1, 0, 1, 2, 3, 4, 5. Right? Then we go. What is the value? The value is 2. So in the destination we go 0, 0, 1, and 2. 2. So right about here, where the 7 is, it will place a 5. And then we increment the value of whatever. So if this value were a 2, we increment it to a 3. Okay. So this is basically what we are doing, is get the we get the count we get the count we get the count of the we get the we point to the position the index in count where the value of the count array where the index of the is situated, and we place the at that position in the destination in the destination array, and then we increment the value. So if there are multiple values, they are situated. Right next to each other. So for example, let me put a file right. Where am I forgetting? So 2, 3, 5, 5, 6, I guess. So first 5 would have been that. I can see it. Here are the 6. Right? Check 0, 1, 2, 3, 4, 5, 2. I have no position 3. 3 is empty. Okay, but 2 then 4. But okay, it defines that its count was 2, right? That 5 had count to 4. It was 2 times. This is the position 6, 5, 5, 6, 9. 0, 1, 2, 3, 4, 5, 2. Then this gets 3. 0, 1, 2, 5 at 3. Okay. Okay, so what we are doing basically is so we have this count array, right? Okay, so we have 0, 1, 2, 3, 4, 5. Say I have the value of the source array. The first value is 500 as a value of, let's say, what was it? 0, 1, 2, 3, 4, 5. Say we, obviously 0, 1, 2, 3. So its value will be here. So say we have this, we go count plus this 5, so 0, sorry, 1, 2, 3, 4, 5. Then you get this value, and this is actually the index in the destination array, right? Say if I make a destination array, I feel like I should do an iteration manually just so I get a little hint of what I'm doing. This will be fun. Okay, so 7, yeah, let's keep it at 7, and I'll construct a new count array. Okay, let me just write the source array first. The source array is 597362 597 3 6. Right. Then we start with that count array. These are all zeros. 10 blocks, so I will make 10 blocks. This, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Wait, let's give them 0, 2, 3, 4, 6, 7. Now I have to perform a cumulative sum. So we have 0, 1 is 0, 0, 2 is 1, 3 is 1, so 1 plus 1 is 2. Because we are doing C of I plus 1 equals C of I plus C of I minus 1. So we start here. We say that current is current plus the previous. So current plus the previous, current plus the previous. 4 is, so this is 0 by default. This is 2. 5 is 1 time, so current plus previous is 3. 6 is 1 time, previous. Current plus previous, current plus previous, current plus previous. Now in the destination, the destination array, right? What we are doing is, I don't need to make this, okay. So first we go current plus 5. So 0 plus 5 is 1, 2, 3, 4, 5. This position, like say d of, what do we say? Okay. First we get the count pointer and we point it to base position plus the offset, which is 5. Okay, so this plus 5, that is 1, 2, 3, 4, 5. So my CP points to index number 4. Okay, index number 4. Then in the destination array, let's say the destination array, value of CP, which in this case is value 2, equals the value of SP. The source point. So that's why I get, so I get in the destination equals here we have 0, 4, 5, 0, 2, 3, 4, 6, 7. I think made okay, doesn't it again. So I get 5 here. Then I move forward. Okay, I also increment the value of this. So now this value is 3. We increment CP at the end, and then we move on to CP plus, let's say 5, 9, 9. So P plus 9 is 0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 5. So right at index 5, we will place our value, that is 9. That is 9. So we get 9 here. Then we move on to 7. So it will give it 1, 2, 3, 4, 5, 6, 7. At 4 is 7. Then we move on to 3. 1, 2, 3. So after 1 is 3. 6. 1, 2, 3, 4, 5. So after 3 is 3 is 6. Okay, but if there were two 5s, right, then this would not have been a 3. It would have been a 4. So it automatically adjusts. Then 4, 2, 1, 2, you get 2 hit. So this is how this works. Space situated, right? So this is my debunk is over, and I can finally understand the whole of the code. So let me just update the destination. Yes, right. Then we perform bytes 1 and 2, and then move on to it later. But this is something. Let's add it. Uh, GitHub C. I'm sorry. Yes. Yeah, this church takes so that's that. We can continue. J J plus J plus 1. Then sort done.